When talking about the nature of geographic information, it's also vital to think about scale and generalization. There are two types of scale that are important for this class: cartographic scale and data scale. Cartographic scale is the scale on the map. This is defined mathematically and can be shown on your map as a scale bar or as a representative fraction. Small scale, aka a small fraction, means that you're zoomed out. Large scale, or a large fraction, means that you're zoomed in. I like to remember it this way: an area appears larger on a large scale map and smaller on a small scale map. This is a multi-scale map. The map on the left side is a small scale map. The map on the right side is a large scale map. These are from a multi-scale map, aka a map that has multiple scales. And this is pretty typical of most maps that you use on your phone or on the web. You can zoom in and get more detailed information, or zoom out and get broader information. So what does this representative fraction mean? USGS maps, which were the go-to standard for maps in the United States, used a 1 to 24,000 scale. Even today, the USGS is responsible for maintaining large data sets of GIS information, which you can get through the National Map website. In the lower 48, USGS maps were produced at 1 to 24,000. This means that 1 inch on the map represents 24,000 inches in the real world. Data scale is a little different than cartographic scale. This is the scale or resolution that geographic information was collected at or digitized at. This has implications for the map scale at which it can be displayed. And I'm going to show you natural Earth data and show you how data scale affects that data. So natural Earth data, it offers a great way to explain data scale, because there are 3 different scales at which you can download data from this site. There are other awesome websites for GIS data, especially when you're making maps at larger scales, aka this isn't great for making maps of small cities like Eugene, but it's great when you're mapping, say, the whole West Coast. When we go to download the data, we see that there are 3 different scales: large scale, 1 to 10 million, medium scale, 1 to 50 million, and small scale, 1 to 110 million. Now let's look at this in ArcGIS. So here's Seattle. For those of you who have been there, you know that there are many islands and inlets. Let's turn on our 1 to 10 million scale data. Here we can see a lot of those islands and inlets, but if we zoom in too far, we can see that this data isn't detailed enough. A lot of the smaller islands have been removed. In this case, we should probably go and get some data which is designed to work at these larger scales. The state of Washington probably has something a bit better for when we're zoomed in this far. Let's zoom out though. To 1 to 10 million. At this scale, the data looks pretty good. But then when we zoom out, say to 1 to 50 million, this data is a little too detailed and the coastlines look really jumbled. In comparison, when we switch on the 1 to 50 million data, this looks a lot better at the 1 to 50 million scale. So here I've got 1 to 50 million data scale viewed at 1 to 50 million cartographic scale. Let's compare again to the 110 million data set. At this scale, this cartographic scale of 1 to 50 million, this data looks a little too generalized. We've lost a lot of information around our coastlines that might be helpful. But if we go to say 1 to 100 million, this data looks all right. we can see the general shape of the countries in this area. But when we zoom in, say to 1 million, we can see that a lot of detail has been removed. So we know that this data, which is the data scale, which is 1 to 110 million, doesn't match our current 1.5 million cartographic scale. How things get represented on a map depends on both the cartographic scale you're designing for, aka the map scale, and the scale at which your data was collected and designed to be used, the data scale. You may need to generalize your data if your data is too detailed for your cartographic scale, aka your data is at a higher resolution than your map. Remember when our coastlines look really jumbled? That's what I'm talking about. So let's talk quickly about map generalization. You might generalize your map by doing things like eliminating information. Here, the smaller side streets have been removed from the second map. You might aggregate by showing lots of instead of showing lots of point symbols all close together, you might just use an area symbol instead. Here, we've simplified the coastline just like we did in Seattle so that it's a little less jumbled. We might also collapse something that's more of an area into a point symbol. While smooth is really similar to simplify, think of smooth as kind of adding more curves and simplify as just removing vertices in your data set. See how this one's a little more angular and this one's more curved. Finally, we might do things like merge. Here, there's lots of little islands that we've now just kind of merged into this peninsula. Now let's recap. There are two types of scale that we talked about in this class: data scale and cartographic scale. Make sure you know the difference. Multi-scale maps are common and popular today. Know what they are and understand how they work. When you zoom in, they show more information. When you zoom out, they show broader information. 1 to 24,000 is a common scale for USGS maps in the lower 48. And finally, generalization is used when your data is designed for a larger scale than your planned map. See you in the next video.